As we've seen from the introduction, x double prime equals negative k over mx is a second order differential equation, an equation involving second derivatives of a function as well as lower derivatives of the function and perhaps the clock time as well. The function, or the differential equation, x prime equals t plus x is a first order equation. We have only the first derivative. T plus x is just an example of a function f of tx, so that the form of this equation is x prime equals f of tx. Now we don't know how to solve this equation yet, and this equation really is not too difficult to solve, but we don't know what to do to get this solution at this point. But here's an equation we can solve. X prime equals t. What does that tell us? Well, if we integrate x prime with respect to t, then what we should get should be equal to the integral of t. That is, if we integrate both sides of this equation, the results should be the same. Now the integral of x prime of t is just our x function, x being an antiderivative of x prime, and a derivative of t is t squared over 2, and then we're going to put an integration constant on it, so that we get solution to this equation, x of t equals t squared over 2 plus c, where c can be any constant. It's our integration constant. Now if we add the condition that x of 0 equals 12, that allows us to evaluate c. C being completely arbitrary allows us to put what we call an initial condition on the equation, a condition that x take a certain value when t takes a certain value. So plugging in 0 for t, we get x of 0, and that's equal, of course, to t squared over 2, let's do this right, 0 squared over 2 plus c, and that should be equal to 12. Of course, 0 squared over 2 is 0, so this tells us that c equals 12. So our solution with our initial condition x of 0 equals 12 is x of t equals t squared over 2 plus 12.